Hey everybody, this is Dustin Mahaffey over at Geekboard Repairs, and today we are going to go over an iPad Pro 11-inch that the client says just sticks at the Apple logo. Currently, I've got no signs of life. It's probably just dead, so we're going to go ahead and plug it in and see what we get. And ignore my camera setup here. I'm still working on how to get all these cameras done properly. So the first thing we're going to do is I'll switch you guys over here to that camera, and we will plug it in to see what happens. All right. And the first thing I'm going to look at is, does it charge? We do get a charging icon here, and then if we look at our current draw, you will see it does charge at 5 volts and 1.5 amps. So that is somewhat normal for this iPad. If the battery is completely dead, which it is, we should expect to see here in a minute or two that it actually jumps up to 15 volts on the power supply. Or I'm sorry, through the charger here. Okay, so before I get into trying to charge the iPad, I did want to go over how I'm charging it. Okay, so the first thing I'm using is an original MacBook charger. This is the 140 watt. This will power any MacBook without a battery and most iPad Pros without a battery, only for a few seconds though. So this is the one I like to use. I'm hooking it up to a PowerZ amp meter. I like this one because it has a very high refresh rate, although it's not cheap. It's like $100 for this. And then an original USB-C to USB-C MacBook charger. They make 2 of these, one for like iPhones and iPads, and then one for MacBook. It's a higher wattage. I use the one for MacBook. That way the iPad will draw as much power as it's asking for. Okay, so I just connect them, the 3 like that. And then we're gonna go ahead and connect the iPad and start charging. So this is interesting. It actually jumped up to 5 volts and then jumped up to 3 amps. That we're still at the dead battery icon on the iPad. Normally what you would see is at this point it would jump up to the 15 volts if it's able to jump up there. But we're gonna go ahead and let it charge at the 5 volt 3 amp and see what happens. Okay, so it just jumped up to 15 volts and 1.5 amps. Which is good. That's what we were expecting, and the Apple logo showed up, so let's switch over. Alright, so this is kind of where the client said it just hangs at. So the next step is to go ahead and open up the iPad. Let's disconnect some of these flexes and go from there. Alright, so we're gonna we got it on the heat mat now. I got the client's information covered up. We're going to go ahead and turn on our heat mats. Just make sure, yeah, we're still at the Apple logo. So let's go ahead and disconnect that. So really the only thing that I'm going to disconnect is the front facing flex, or the proximity flex on the iPad, and see if that allows it to boot. A lot of times what will happen is we'll get a little bit of liquid in there, and then that will cause it to hang at an Apple logo. So while we wait for this to get hot, well, that should only take a minute. Okay, so while we wait for this iPad to heat up, I'm a little disappointed because I was hoping that it wouldn't jump to 15 volts, because then there was another issue I kind of wanted to go over, but it doesn't look like that's it. Hopefully this isn't just a proximity flex. I'm going to disconnect that first and see what happens, because if it is, then I don't get to make a video. But hopefully it's not. Hopefully it's something more complex, or a more complex issue than a part problem, so we can have a good video. Ooh, look at that from the heat on the thing. It's not even that hot. This must be some type of aftermarket screen. Hopefully we didn't damage it, but I doubt it. It's probably just because of the heat. And yeah, opening right up, you can see the Apple logo coming back. The screen going back normal, so I did not break it. Good, okay, so our first thing was disconnect the prox. Come on, lift up. And if you can see, that's not even connected. They already tried a charging port. Okay, so what's our next step? Essentially, the next step I guess would be trying to update it. But thinking about it, I guess we could try to disconnect the rest of these flexes to see if that's the issue. See if that's the issue, and then go from there. So let's go ahead and do that. All right, slide that in there to restart it. Take it out. Put my battery screw back. Okay, so now with all the battery screws, or all of the flexes disconnected, we're gonna, and I reseat the battery cable so it's restarted. Let's see if if it actually boots. Gotta prompt boot the charging port, because of course I unplugged the power button. Alright, so we are getting a healthy charge current of 15 volts and 2 amps. And this is sent in by a shop, you know, that does repairs. So I'm sure they've already tried this. They tried the battery and everything. But as a micro solder, I always just want to confirm that these parts are not the issue. Alright, so we're going to go ahead and disconnect the battery and then try to boot it into recovery and see if it will recognize the computer. Okay, so I just plugged in the power button and notice I disconnected the battery for that because I am connecting the flexes. We're going to go ahead and put the battery screw back in and connect it to our computer and try to boot into recovery mode. At the same time, plug it in and hold the power button, and this should boot it into recovery. Alright, so it's not booting into recovery. So why is that? That tells us a couple of things. It could either tell us A, that the power button is bad, not likely but possible, or B, that our charging port is bad. Now you can see there is a new charging port installed on the device, so that's also not likely, but let's go ahead and try to rule those out. The power button is going to be the most simple to rule out, simply because all we have to do is reseat the battery and try to prompt the boot with the power button, and if it does, then the power button's okay. And then the next step will be go ahead and change the charging port and run that test again to see if it actually boots into recovery this time. Okay, so we have our port swapped out, and so we're going to test the port and the power button here real quick. So I'm just going to pull out the bag real quick, and we're going to test our power button, see if it prompts the boot. Oh, it doesn't. Make sure the battery's... Oh, yeah, yes it does. All right, the battery wasn't pushed down enough. Okay, so power button is okay. So what we're gonna do now, excuse me, is go ahead and disconnect the battery again, get the iPad to turn off, put the battery screw back, and again, I doubt this is gonna work, but we're just doing this to confirm that there is no part issue. And once again, come on, we are going to get our cable and at the same time plug in and hold the power button and see what we get. Nada. Still not going into recovery. Okay, so our next step is to try to figure out why it's not going into recovery, which may seem like it may seem like a more complicated issue now, but it's not. It's actually a lot more simple. And because I say that because the Apple logo, being stuck at the Apple logo can mean so many different things, and it's hard to narrow those down, right? But not being able to communicate with the computer and not going into recovery or DFU is very telling. It tells us that likely our issue is in the charging circuit, or more accurately the PC communication circuit, which also happens to be in this charging circuit on this device. So how are we going to find out what our issue is? Well, we're going to go back to basics and we're going to diode the charging port connector and see if anything seems weird there. So let's go ahead and do that now. Okay, so here we're at our port, and we could go pin by pin and match them with ZXW and figure out what's short. But I'm going off of experience, and I've seen this issue before, so I'm gonna jump to what I think my issue is gonna be. And these resistors, these resistors right here are responsible for PC communication. So I'm gonna check them. That one's good. It comes to about 0.720, 0.720, 0.575. That's low. It should be like the rest of them, 0.7. And ooh, you hear that? That is 0.069, so that is a partial short. That should not be there. Okay, so that is going to be our issue. Now let's go ahead and pull up ZXW and see where that goes. Alright, so we found our issue. We have a partial short on two lines that are used for PC communication. So it seems like it's going to be a very straightforward issue, but let's go to ZXW and see what ZXW has to say about it. Okay. So iPad Pro, yeah, we're not doing 12.9 right now. We're in 11-inch, and this is a second generation. No, that's the wrong one. I think it's this one. Maybe, we'll see. Yeah, I think it's this one. Okay. All right, we're gonna flip around to match the view that we had over here. Okay, and the first resistor was the one that was short here. Okay, so let's zoom out. The other one side of the resistor goes straight to the connector and a diode. I guess technically that diode could be shorted to ground because it does have a leg on ground here. Not likely. Let's see what's on the other side of the resistor. A CD3217. Okay, and that's literally the only other thing. So we have a diode, connector, and a CD that could be shorted. So we know our issue is going to be either that diode or the CD3217. Now why do I say that? Why can't it be the resistor or the connector? Well, because simply it has to have a path to ground, or it has to have a leg on ground. That resistor doesn't have a leg on ground, and while the connector does, it's not likely unless there's some type of liquid damage or something like that causing the two pins to short together. You'll be able to see here that while technically, yes, the connector does have a leg on ground and it's right next to it, the chances of that happening with no liquid damage or any type of damage there is slim to none. Now, the diode, it could very well be the issue. It does have a leg on ground right there that could short out. It's possible. Okay, so how can we identify whether it's the CD3217 that's shorted or the diode, right? A couple of different ways. One, we could inject voltage on something like that, or a communication line. I'd probably just inject 1 volt and see what gets warm with my thermal camera. That would work well. Or what we could do is remove the resistor and see what side the short is on. That would also work. But what we're gonna do is actually just remove the CD3217 and see if the short is still present on those two lines. And I'll tell you why, right? I'm using a little bit of logic and experience here. So the fact that the iPad is stuck at the Apple logo is very telling, right? If it was the diode itself, what we would expect to see is like no PC communication, but iPad still boots up normally. The fact that it's stuck at Apple logo tells me that some more communication lines besides just that the two that we checked are shorted, causing the rest of the iPad not to be able to communicate properly and boot up properly. So again, since the CD has so many lines underneath it that have the probability of being short, I'm leaning more towards the CD being the issue. So what we're gonna do, again, is just remove the CD, and then the iPad should boot up normally. Now it won't charge, obviously it won't charge or have PC communication, but it should boot. So let's go ahead and do that now. So there is the chip there. Try to get this in focus for you guys. Now, this is right next to the battery. So what we're gonna do is I'm going to take one of these things that come with your iron to protect your hands when hot swapping a port. We're going to take some aluminum tape here, and what I do is I just take this, get this back off of here like that, take this off, and I kind of stick it on the edge of my little thermal pad here, just like that. So just the edge sticky part is showing, and then I'm going to put that, switch over the scope so you can see it, zoom out as much as possible, kind of right here on the frame of the iPad, and have it stuck there. And then, so no, I'm not removing the board out of the housing, and I've never had a battery excuse me, I've never had a battery blow up at me, but this being my first video in over a year, that would just be my luck if it happened. So removing the CD. Now, since the housing is in the board, it is going to take a little bit longer, or since the board is in the housing, it is going to take the CD a little bit longer to remove, simply because of that it's like acting as a heat sink, the housing is, and it takes a little bit longer to come up with like that. Oh, there it comes there. And we're going to put, what is this, a CD B12. Okay, so I'm pretty sure I've got some donors that have the B12 on there. All right, so what we can also do here is check the readings on this here, right? And we should have OL. On this one we have OL, on this one we have OL. On this one was a partial short at 577, and it still is a partial short, which means that that diode is bad. And on this one we also have a partial short still of like 0.800, so it's not as short as it was. We still have a short on these two lines, and it's because of these two diodes here. But I bet you this iPad will still boot. So let's go ahead and put the screen on. So now that we've removed the CD, which in my theory here is shorting not only those two PC communication lines, but shorting other communication lines, causing the iPad being stuck at the Apple logo. now that we've removed that CD, hopefully remove the short from the other lines, even though we still have a partial short on those two PC communication lines. So we got the screen on there now. Get the battery connected. Hopefully we have enough charge on the battery to boot this. So let's go ahead and see. Please have enough battery to boot. All right, we got Apple logo, that's good. Okay, come on, boot for me, baby, boot. This isn't a good sign. This is not good. This is not good. It booted, yay! All right, so we have somewhat fixed our issue, right? Still not charging and it still doesn't have any PC communication, but at least we got it to the lock screen. We are making progress. And it said failed and unable to activate Face ID, and that's likely because all of the flexes are disconnected. So what's our next step here? Just to turn off the iPad. Our next step is to go ahead and address the two diodes that are short. Remember, we're supposed to have OLs on those two lines whenever there's not a CD on the board. So that means that the diodes are short as well. So we have to replace those. All right, let's go ahead and remove these diodes. Hopefully, I do not melt this connector on my video, because that would be embarrassing. Now, this diode has a leg on ground, so it does come off at a higher temperature. Alright, you see there's the first diode off the board, and we're going to go after the second now. And there goes the second. Alright, so now we have those two diodes off the board. What we're going to do now is check to see if they are OL or still have a partial short. It would be impossible for them to have a partial short now, unless it would be the connector, which again never happens without any liquid. Okay, so we have OL there, which is good, and OL here, which is good. Alright, and then we should just double checking, so OL's over here. Alright, perfect. We are good to go. Now we can go ahead and start repairing the iPad. So we'll go ahead and put a dab of flux right here. Alright, get our micro iron. Wait for it to get hot. Beep. Alright, we're good. Okay, so we'll add a little bit of solder to our iron. Hit the ground pad first. Come on. A little more solder. Oh no, way too much. Way too much solder. A little bit there, a little bit there. Oh my god, I'm making a hot mess over here. Alright, what happens when we make a hot mess like that? Easy, look, let's see, make it so you guys can see a little better. Alright, I made a mess because I was shaking. Look at that, I got solder everywhere. Let's get that cleaned up so you guys can see the mess I made. In all fairness, it is a pretty tight fit in here. Okay, so look at that, I got a glob of solder where it doesn't need to be. I got it on the connector. What is a ginger to do about this? First, let's see if we can focus you up any better. Alright, so we're going to come in with a little bit of wick, but it's a tight fit to get wick in there, you might say. It is, you're right. So what are we going to do? We're going to use wick and hot air. So I'm going to cut off a little piece of wick. Switch it back over to me. I'm going to cut off a little piece of wick like this. I'm going to fold it across my tweezer like that, okay? Take my tweezer out and grab it by the top. And now I have kind of a little more hardened piece of wick. And then we're going to use hot air to get that extra solder off the board. Alright, that's not one to suck up. The little bit of flux that is on the wick is not enough. That's no problem. Perfect. Alright, now we have even pads on all where the diodes go. Now let's fix this mess that I've been making over here. Oop, put one resistor back, grab the other one here. Come on, let go. Alright, that's close enough. Surface tension will let that work. Perfect. You see, I made a mess. I made a bigger mess, and then I fixed it. Right, let's get our flux cleaned up here. Alright, that's all clean. We're going to add just a little bit of flux here so we can get our new diodes on there properly. Alright, so now we got to go get a donor board. Alright, so the next step is to go ahead and install another CD3217. Now, you could try to buy them from Mobile Centrics, but if they're not pulled off an iPad, they will not work. If they come from a MacBook, they won't work. So I tried just to pull from donors, so I have to go to my donor stack and hopefully find one. I think I have one back there. I'm pretty sure I do. Alright, so I found a donor. I found a donor here that we're going to pull the CD off of. Get us both in focus if I can. Beautiful. That's off of there. Let's go ahead and get this reballed. Alright, that looks good to me. We're going to put that chip aside, get our board ready to install it. Definitely could use more flux, but I'm already committed now. Alright, that should be good enough. That looks good. That looks wicked enough for me. Alright, now the board should already be warm, so we're going to apply our flux now while the board is warm, so just kind of very thin layer of it. Just like that. Okay, so we're going to go ahead and install the CD, put it kind of about in the right position there. And again, you see I'm using very little flux, and that's just because I want the board to look untouched as possible when I'm done. So that means as little flux as possible. Now what we're going to do is have surface tension come into play. As soon as that chip moves, we're going to knock it a little bit, just like this, whoop, and to know it's in position. Now it's in position. Technically our repair is done, but I do want to clean this up a little bit. I don't want to leave that much flux on the board. So we can kind of take some ISO. It's going to be hot, but that's all right. So now, if we've done our job properly, not only will the iPad continue to turn on, but it should charge the battery that's in there. So that is the next step, is go ahead and test all that. So let me get all of these flexes put back in place here. All right, so now that I've put it all back together, sorry I got a phone call during that time, so I just put it back together. But you can see it is still booting, and you have to trust me, it's pulling 15 volts and 2 amps, which is exactly what we want it to do. Maybe I can get the glare. You can see there's the amp meter right there in the glare. You can see it. The 15 volts and 2 amps. We'll wait for it to boot. And it boots and still has touch, maybe, yep, there's touch still. And it's charging, as you can see up in the corner, it's charging. So we are good to go. This will be hopefully a happy customer.